Hello, everyone. My name is Yun Xiao, and I'm going to talk about this 2021 paper by Wang Ziqin and the team. It is called CLEVE Contrastive Pre-training for the Event Extraction. I selected this paper because it used some pretty intuitive method for such tasks, which I think give interesting results. In this research, those people proposed a framework for the task extraction for the event extraction, and they tried to take the advantage of the unsupervised data. The framework is named CLEVE, and it is a contrastive pre-training framework from event extraction to a framework that can actually better learn the event knowledge from large unsupervised data and their semantic structures. So the key is the semantic structures. Let's take a look at the research problem. So, to know how good is this model, we have to maybe think about what the old model did. So, the task of event extraction, essentially, for example, here we have a text called CNN's Kelly Wallace reports on today's attack in Netanya. And essentially our task is essentially to extract the event from this piece of text in a preferably unsupervised way, which means to get the event type attack here. As you can see, the rectangular attack on the right side figure. And also at the same time, we also want argument rows like time, place, target, and who's the attacker. So speaking of semantic structures, this framework will use informations from automated extracted semantic structures using AMR parser. So the previous pre-trained model on event extraction have essentially not involving any modeling event characteristics, which means they're like pure text coding encoding based, which results in the event extraction model are not actually taking the advantage of all the unsupervised data. So the essential ideas are on top of using the pre-trained language model, we're going to actually crack the event extraction from two aspects. The first aspect is to use the semantic structure representation, which is through the manner of self-contrastive learning. And the second part is essentially to select the correct event structure using the event structure representation. And there are three steps in the construction of this event extraction framework. The first step is to pre-process to get the AMR structures of the corpus. The second step is to train the encoders for the argument pair discrimination, which is used in event, which will be used in the event structure pre-training. And the final step is to build a graph encoder on top of the pair discriminated nodes and also construct the discrimination mechanism on the AMR subgraph. So what is a AMR graph? AMR graph is defined using words as vertices, and we are going to use their semantic relations as edges. Example AMR parsed graph generated from CNN Kelly Wallace report is shown on the right side, as you can see. For example, today is a word from text, and time is a relational type. So no wonder like today is a vertice, right? So after getting all the AMR graph, which is the foundation of the following steps, we're going to construct event semantic trigger argument pair discrimination. The essential idea is to learn closer representations for the words in the same event than the unrelated words. And here we're actually training a text encoder as you can see in the middle. And here we can see W as our trainable matrix weights, and we're actually using this training objective to essentially learn the similarity matrix between words in the corpus events. At the end of it, we will have a text encoder and W that triggers the argument pair discrimination. Besides the text encoder for the event types, we also want a graph encoder that can pre-train the graph structure in the same fashion. The node initialization essentially comes from the text encoder that triggers the discrimination on different types of events, for example, attack, and we will use the corresponding text representations from the text encoder as the initial node. And after all those preparations, we're actually doing the event structure pre-training now, which is a discrimination on the AMR graph that was generated from the parser. And we're using the graph encoder with previously initiated nodes to structure to build up and generate the subgraph for the event. And we can see here the discrimination system gives the labeling that the first attack today, Natanya, is the event to represent the sentence. If you check it out on the right side figure. So, what experiments did the did the team do? We can see that the corpus they used was New York Times, and they used a pretty new version of AMR parser, by Team Xu, along with the text encoder, which they're using Robota here, and also the graph encoder. The model is called graph isomorphism network. The parameters are listed here. The CLEVE has two different settings, the supervised setting and also the unsupervised liberal setting. Here we adopt for the supervised setting, we adopt the dynamic multi-pooling mechanism for the text encoder, and also they encoded the corresponding local subgraphs with the graph encoder, and then they concatenate two representations as features, and then they fine-tune the CLEVE on the supervised dataset with annotations. Um, yeah, and we are actually more interested in the unsupervised liberal setting, and actually they follow the overall pipeline of Huang, which is shown on the right side, and they directly use the representations produced by the pre-trained CLEVE, and as the required trigger and as the required trigger semantic representations are done, they can actually get the event structure representations. The unsupervised liberal event extraction actually requires to discover event instances and event schema only from raw text. So here are the results. If we can take a look at the actually supervised setting first. So the result for the supervised setting is shown here, and we can say that the performance is kind of okay as it gets the best score on both event detections. However, in the supervised setting, it is not as competitive as other supervised methods on event argument extraction tasks. Well, but we are indeed more interested in the unsupervised liberal settings, right? So let's take a look at the unsupervised liberal setting results. So the results from CLEVE on the unsupervised liberal setting is actually pretty good, as it gives all the best scores on event detection and event argument extraction, and especially when compared to different text encoding methods. Uh, that can mean that using the sentence structures from AMR does have a change to the performance and enable the framework to learn from more of the corpus from an unsupervised dataset. There's one thing that is needed to be mentioned, which is the metrics. Here it is using B cubed metrics. So the conclusion is that the team proposed a CLEVE as an event extraction framework that actually uses sentence structures from parsed graphs, AMR structures, right? So, and also have a pretty good performance when compared to other text encoding event extraction methods. The results are pretty promising, especially when everything is compared under unsupervised settings. So yeah, we can saw it here, right? So the authors mentioned that in the future, there's for the future works, the author just mentioned that in the future there's possibilities to probably explore other types of semantic structures, and also maybe try to attempt to overcome the noise in the unsupervised data, which is brought by the semantic parsers. So this is essentially my presentation, and I personally think it is a pretty good paper as It kind of like introduced a way of event extraction using the semantic structures from the raw text in an unsupervised manner that I feel it is pretty applicable in a lot of situations. And here are my references, and including all the figures that I use from different papers. Thank you very much. This is my presentation.